Hello everybody. So 9.5 talks about graphing other trig functions. And this can get a little spicy here because we're looking at a tangent cotangent function which end up having quite a few asymptotes. So if we're to look at this here, let's say let me actually do it like this. So let's take a look because again we're going to go by units of pi over 2, so but if we think about our tangent function, it's just the ratio of the sine over the cosine, right? The opposite over the adjacent. So we know that when our input is 0, our sine is 0, right? And then actually we maybe here should try to adjust because we know that at pi over 4, halfway through here, right, on our x-axis, we know that the sine and cosine are the same, which would give me this value of pi over 4 as my x, an output of 1 there. And then what actually is going to happen at pi over 2 is it's actually going to be asymptotic there, because if we think about it, that's where my cosine value is 0, and I can't divide by 0. So as we get closer and closer and the cosine value gets closer and closer to 0, we're getting a number divided by something very tiny. So it's just going to, which gives us a really big number, which will give us something that's going to be quite large. So it actually has an asymptote there. Let's actually start by going the opposite way. Well, at negative 45 degrees or negative pi over 4 radians, we're just going to have the exact same relationship except negative, because my cosine is positive but my sine is negative. But then I have the same thing happening where it's going to become a really big negative number as my input approaches negative pi over 2 from the positive side. And what is actually going to happen is that this shape is going to repeat itself in every one of these little things. It's going to have lots of asymptotes along the way. So it's going to look something like this. And again, at 2 pi, we would have it again. And so we would have the same thing here at negative pi. And what we could then do, if we wanted to, we could put in a line here to show these asymptotes. We've got one happening here, another happening here, another one here, and another here, and another there. And that pattern is going to repeat onto infinity, because as we keep going around and around and around the circle, we're just repeating this pattern over and over and over again. Cotangent is just the reciprocal of that. So what actually is going to happen is that for cotangent, you would have your asymptotes at where we have an output of 0 now, because it just means that instead of 0 being divided by something, we would have something divided by 0. You could graph these on Desmos or on your calculator to get a good image of them, but what you'll end up seeing is that these graphs, they only have a period of pi here, because if you look here, it's just this pi, it repeats, then another pi, it repeats. So the period is only pi for the tangent and cotangent graphs. How would we express the amplitude? Well, it goes on to infinity in both directions, so we can't really give this graph an amplitude unless we said it had infinite amplitude, but because they do not have maximum or minimum values, and because infinity is not a number and the range is all real numbers, we would just say that these graphs do not have an amplitude. I hope that this was helpful for these funky graphs that really do look quite unique, but hopefully you're able to understand why they look the way that they do. All my very best, Mr. Tan, and signing off.